experience. He has a very vast experience into recycling, and today he's going to share more about. He's going to share his experience and knowledge around recycling. And before we move ahead, I would like to share a few details about CECA Asia, what we do, what are our services. Yep. So first of all, very happy New Year to everyone. And we are Composite Excellence Center of Asia, and we continue to support for skill development in the industry. And we believe there is a pathway to skill development, which is blue collar, white collar up to top management. We have partnered with multiple universities. We have signed MOUs with industry with these universities to develop industry ready curriculum, and to work together to create an environment that enhances the talent, brings good labs, and let people work on good projects, especially the students. We also have membership, individual membership, corporate and own membership. Membership welcome each individual to the composite village, the community that we call, and the individual membership, you get access to the knowledge and updates. You are able to join, and you get notifications on the programs and the webinars that we conduct, and we host small sessions offline in Vadodara, Ahmedabad, and other cities where you can network and feel free to connect with the people in the composite fraternity from industry and academia. And then we have corporate membership, where the industries are uh, they get priority training and mentoring sessions from our veterans in the composite industries. We also provide free membership resources and books which are related to composites. Then we have honorary members for the people who have spent their like more than 25 years of their life into composites. So it's an honorary membership given to those people. We have multiple services that we provide at CECA Asia. The key services include, we have a composite directory where you will find all the, anything and everything related to composites, including the industries, the academia, and consultants and everything. Right. We also have a composites industry manpower data bank where you can enroll yourself. Manpower data, corporate membership members that we have, so you get the opportunity to switch between your job and see an industrial growth in your in your career in composites. I'll request people to mute if possible. Yeah, thank you. So we also provide books on polymers, fibers, composites, and management for the corporate members. And we run multiple courses, which includes FRP, corrosion, which is like methodology based, and the tools based, materials based. So we have specific courses that we have. We also publish CECA Communique quarter on quarter, which you can find on our website. And as discussed earlier, we maintain a manpower data bank for our corporate members. So we are celebrating the composite value chain, like from shop floor processes to world-class applications. Wherever possible in composites, we try to bring more and more knowledge to the people within and outside the composite industry to whether it is the process like pultrusion and layer RTM or pressing. We try to impart knowledge, bring veterans from the industry to impart knowledge and discuss on these the processes which are included composites, and share the knowledge around it. So in 2026, we can in previous slides focusing more on courses. We'll be focusing program be more related to our process with universities to bring in sessions which are conducted by the industries, and there are other activities that we have planned with the universities, like for the students and the professionals in composite industry. We're also planning to bring more webinars and networking sessions for the industry and academia, and we continue to support MSMEs to bring them more strength in market and help them build their capabilities. And to hear more about CECA Asia, you can visit cecasia.com or cecasia.org, where you will find all the details. With that, thank you so much for joining today's webinar. I'll stop my screen share. I request Mr. Ulhas Parlikar sir to share his screen and start the presentation. Thank you all.
Thank you, Dr. Singh. Let me share my presentation with you.
Entire screen is burned up, taka? Select करा. ठीक है?
Participants, if you have any questions while like Mr. Ulhas is giving his presentation, you can log them in the chat. We'll take all those questions at the end of the presentation.
Okay, so is my screen visible?
Yes, sir, your screen is visible and you're audible.
Good. Thank you so much. And thanks, CECA Asia, for giving me this opportunity to share some of the aspects related to sustainable management of FRP and SMC waste through co-processing in cement kilns. Actually, as was shared with you, I was a part of ACC Cement, where I worked on building this concept of utilizing different kinds of wastes as fuels and raw materials in the manufacture of cement. I initiated this activity in 2006, and we first demonstrated for different materials like plastics, normal plastics, and then different chemical wastes, then petrochemical waste, then pharmaceutical waste, then automobile waste, etc., etc. And slowly, we also able to demonstrate that we can utilize the FRP and SMC waste. We had we actually had made a contract with Suzlon at that point in time from their Pondicherry site, and the material, we did a trial in our plant in Coimbatore, near Coimbatore. And this trial was plant scale trial to demonstrate that it is safe environmentally as well as occupationally to utilize FRP waste or SMC waste as a fuel and raw material in the manufacture of cement. So this trial was done, I think, around 2008 or so, 2008, 2009. And this submissions of the results of this particular trial were given to Central Pollution Control Board and State Pollution Control Board. There were several discussions subsequent to this particular trial, and the permission was given to us by the Central Pollution Control Board and the Tamil Nadu Pollution Control Board to start utilizing this FRP waste as an ingredient in the cement manufacturing at our plant in near to Coimbatore in Tamil Nadu. So this was a journey, and we must have consumed substantial quantities of material from Suzlon and subsequently from several other blade manufacturers. See, we did not have an opportunity to interact with smaller players, who are making the FRP or SMC products. Mainly, we have been able to demonstrate it for the wind blade and related applications. But there's no reason why, we cannot be done for any other kind of FRP or SMC. There was a time somewhere around 2000, I think 13 or 14, when the NGT had asked Central Pollution Control Board that is there a methodology available for sustainable management of this FRP and SMC wastes. And since this particular trial was already done by us, so CPCB had invited us to be a part of that particular committee and then draft out an action plan and a report and subsequently guidelines for utilizing such materials in the cement kilns. And I was a part of that. Along with Central Pollution Control Board, we prepared a particular guideline, which is very much there on their website even now. And with that confidence, I'm saying that it is substantially possible to utilize this particular waste material in an appropriate manner in the cement kiln and recover whatever value, material and energy which is present in this material that can be utilized, and we can avoid a lot of environmental concern that we may have on account of the generation of this particular waste material in our manufacturing facilities. So let me begin first. I hope my screen is moving. So I'm going to describe co-processing technology now. So it is a thermal treatment process to utilize wastes as resources in resource intensive industries. And which are these resource intensive industries? These are like cement kilns, thermal power plants, steel plants, glass manufacturing plants, refractory manufacturing plants, lime plants, etc., etc. Although, it is said that we can utilize, co-processing is very, very feasible in all such resource intensive industries. Predominantly, cement industry has been the one which has been at the forefront, and a substantial amount of waste materials are utilized by the cement kilns in India as well as globally. When I started this particular initiative in 2006, we were hardly utilizing any waste material as resource in our cement manufacture. But if you take today, which is 2026, let's say about 20 years after that initiation, today we consume more than 6 million tons of waste as resource material in the Indian cement industry. So that's the kind of gigantic capability that the cement industry has been able to put forward to the society and to the industry in our country to manage different kinds of wastes. What happens is that the wastes get utilized as alternative fuels and raw materials. And in short, we call them as AFRs in this resource intensive industry, and they replace the fossil fuels and the fossil raw materials that we normally use in this resource intensive industry. You take any resource industry, if you take thermal power plants, you use large amount of coal. If you take steel plants, we use large amount of iron ore, large amount of coke, which is made from coal. If you take glass manufacturing plants, you use a lot of, the mined materials for manufacture of glass, as well as a lot of energy, which may be derived out of coal. Refractories, again, a lot of mined materials are used, similarly lime. So therefore, if we substitute these fossil materials with these alternative materials, you are not going to utilize the fossil materials at all. So if you don't utilize, say, 1 ton of coal, while replacing that coal with some waste material, let's say FRP, that 1 ton of coal since it is not required, it is not to be mined as well. So that material, 1 ton of coal, will remain in the Mother Earth. And that means it will get conserved for years together. So in this approach of utilizing waste as resources, we used to call that we don't want to mine the earth. We mine the urban areas or the industries or the society and try to find out the waste which are there and mine them and utilize in our manufacturing processes. So that's the kind of capability this particular co-processing technology has. So we have different kinds of alternative materials which can be used to replace the fossil fuels and fossil raw materials, and therefore we'll be conserving these fossil materials and thereby reducing the global impact that we talk about in terms of the greenhouse gases or in terms of the other emissions that tend to happen while we utilize the fossil materials. What are the advantages of co-processing in cement kilns? So if you co-process waste as resources in cement manufacture, first it reduces the number of landfills because otherwise the waste material tend to go into the landfills only. The second is the pollution which would have been caused by way of dumping the waste material onto the lands, that pollution would get substantially reduced. The greenhouse gas emissions, I already said, they get reduced because you don't use fossil materials. Environmental impact of the extraction of mining is no longer there because you are going to reduce or avoid mining fossil materials fully. Dependence of primary resource markets also is going to get drastically reduced. And the cost of production of cement will get down drastically because once we use waste materials, they are substantially cheaper in the marketplace. And that's how we are able to produce cement at a lower cost. So this particular approach mitigates climate change. It conserves energy and material resources. And important thing is that it involves a highly organized industrial sector. It is not a small industry, which may get shut down tomorrow. So if you have a solution, if you have resorted cement kiln application for the management of your waste, this industry is not just going to go out. It will be always there because the major pillars of the industrial growth and growth of the countries. So, and it's a highly organized, there are processes, systems in place. There is nothing that cannot be said as being done in a what I should say, in a clandestine manner. Everything is transparent, everything is clear. So if you are sending this material to the cement kiln, there would be a very clear understanding that you will have in terms of how it is getting utilized, where it is getting utilized, how much it has got utilized, whether it has been utilized or not. And there will be an accountability which will be there with you for the waste that you generate and for its sustainable management. So those are the advantages of this co-processing of waste in cement kiln. And most importantly, this particular approach promotes the circular economy because you're allowing the resources to remain in circulation by utilizing these waste materials. Otherwise, these waste materials would have been in the junkyards or in the dump yards or in the landfill sites.
Ulhas sir, I think we're not able to hear you. Hello, Ulhas sir. Are we audible to you? Hello, Ulhas sir. Are we audible to you? We could see that the slides are getting changed, but we're not able to hear you.
Audio is muted.
Somebody has muted me, actually. Am I audible now?
Yeah. Yes.
Yes, sir, you're audible.
Yeah, somebody had muted actually, that's why. Okay. So can you see my screen?
Yes, sir,
yes,
yes,
sir.
visible.
Okay. Okay, fine. Okay.
Yep. We are on the co-processing. Yeah.
Okay, right. So I talked about the combustible material. The organic content is combustible and gets utilized as fuel material. And the inorganic material, these are normally oxides of calcium, iron, silicon, magnesium, and aluminum, etc. So these get utilized as raw materials in the manufacture of cement. So therefore, every element, every constituent which is present in the waste, it gets utilized in the manufacture of cement, whether it is organic or inorganic. And therefore, when we use waste material as alternative fuel and raw material, there's absolutely no residue from the process. Everything, every gram of the material out of tons of material that you will put into the process will get utilized. So that's the advantage, that's the beauty of this particular co-processing technology. And this is very widely studied, evaluated, accepted. This is accepted by Basel Convention, Montreal Convention. This is approved by Central Pollution Control Board. Even Supreme Court has given its Supreme Court committee, I'm sorry. They have given its acceptance for this particular technology. So there's no cause of concern from any consideration for the towards the utilization of waste in cement kilns. There's also a policy framework which has been drafted and notified by the Ministry of Environment, Forest and Climate Change in 2016. And here it says that for management of industrial hazardous and non-hazardous waste, plastic waste, agricultural waste, and other combustible waste, co-processing is an acceptable technology. So if you are sending the material for co-processing in cement kiln, I mean, even FRP and SMC, it is absolutely acceptable. Only co-processing technology has concerns if we are going to utilize the ozone depleting substances or perceptible organic persistent organic pollutants or the polychlorobenzenes, then there's a cause of concern and there's a requirement that Central Pollution Control Board or the Basel Convention has laid, which we have to follow. But otherwise, these materials can be very, very safely and in environmentally sound manner, we can utilize them. These waste materials can be sent for co-processing to the cement plant, to any cement plant. Only condition is it has to have requisite permission from the State Pollution Control Board. And there's a process in place for that. And many of the cement plants, in fact, almost all the cement plants that we have in the country, they have the permissions to co-process waste materials. Internationally, as I said, co-processing is recognized by various, whether it is Basel, Montreal, Stockholm, and several other conventions. So there's no cause of concern of any kind for the utilization of co-processing technology for management of waste. What are the salient features of the cement kiln? So if you look at cement kiln, it is a gigantic facility. There is this brown cylinder that you see. This brown cylinder is called as cement kiln, this one. And there's a flame here. This flame will be having temperature of more than 1800 degrees centigrade. We fire for fuel through this particular burner here. This is a rotating kiln. It rotates at something like 3-4 RPM. And there is this particular cyclone infrastructure, which is called as preheater. Today's kilns, which we are building in India, this cylinder will be about 6 meters in diameter and 100 meters long. So that's the big equipment that will be there in the cement kiln. And this preheater tower, this tower will be about 150 to 180 meters tall. So this will be a very big, gigantic facility. And such kilns which are being built in the country today, they process approximately 18 to 20,000 tons of material every day. So you can imagine, 20,000 tons of material every day it processes, and we get the cement out of it. So we will be feeding the waste material or the FRP or SMCs into such cement kilns, which has that giganticity. Then it has got this temperature here in the flame, which is about 1800 plus degrees centigrade. The residence time of these particular gases in this kiln will be about 6 to 10 seconds. Normally, when we design any incinerator, the norm is that it should have 1100 degrees centigrade and 2 seconds residence time. Here we will have more than 1100, that is up to 1800 to 2000 degrees centigrade, and the residence time will be 6 to 10 seconds. So it is, in terms of residence time, it is maybe 3 to 5 times more than what the incineration design demands. And then if you look at the temperature is almost double. So that's the intensity this particular cement kiln has got. And whatever material that we put into the cement kiln, the organic material gets completely combusted, and the inorganic material becomes raw material in cement manufacture. You may have some chlorine, you may have some sulfur, you may have some nitrogen in the waste material. So they will get oxidized. So chlorine probably, will become HCl. Sulfur will become sulfuric acid or sulfurous acid. Nitrogen will become nitrogen oxide. Phosphorus will become phosphorus, phosphoric acid or phosphorus acid. Fluorine will become probably, hydrogen fluoride acid. But all these acidic gases, excepting the nitrogen oxides, they all will get trapped in the lime, which is used as raw material in cement manufacture. Lime is a highly basic material, and all these are acidic materials. They react in this 150 meter, 180 meter tall preheater tower that we talk about, where we have a countercurrent exchange of heat happening from the hot gases to the cold material, which is coming down. And that's where the reaction happens and all the acidic material is trapped. So in the emissions, there's absolutely nothing. Nothing will go out. The combustion efficiency of this particular cement kiln is very high, in the sense that if incinerator requirement is 4 nines, that means 99.99% destruction of the organic material has to happen as per design. We have measured the combustible efficiencies of the cement kilns, and they are up to 9 nines. That means 99.79. So that's the kind of capability that the cement kiln has got, and therefore There's absolutely no cause of concern on the emissions like dioxins or furans or any other kind of acidic gases or VOCs. So hence, this particular cement kiln technology or co-processing technology is a very, very safe technology for utilizing any kinds of waste. Just to add value to the discussion that we are having just now, I have been able to demonstrate destruction of expired pesticides, then FMCG, various kinds of materials, then the ozone depleting substances, FRP and plastic waste I already talked about. So variety of hazardous, non-hazardous materials, including the combustible material from municipal solid waste. So today, when I said that Indian cement industry is utilizing more than 6 million tons of waste as fuel, almost 5 million plus tons is RDF from the municipal solid waste. So that's the giganticity that the cement kiln has got, and that's the giganticity with which we will be utilizing the waste material as resources in the cement manufacture. How does it help in reducing the greenhouse gas emissions? So if you burn the or landfill the wastes into in the environment, they will anyway release the GHGs, whether they are carbon dioxide, SOx, NOx, ammonia, whatever, all kinds of GHGs. And cement kiln anyway is required to produce the required quantity of cement. But suppose some of the waste material is able to replace some of the fossil materials, to that extent, the fossil material utilized come down and there are no emission. Are you able to listen to me?
Yes,
Yes,
yes.
sir.
So this
Yes,
is how
sir. Yes, sir.
the utilization of waste reduces the greenhouse gas emission. In fact, this technology, co-processing technology, is one of the prominent technologies for decarbonization of the cement kilns today. And there are cement kilns in the world which operate almost at 90% of fuel replaced using waste materials. And in India, we have several plants today which are able to replace up to 40% of its fuel requirement with waste materials. So that's the kind of capability that the cement kiln has got in ensuring that the GHG emissions or GHG impacts are drastically reduced while we utilize waste as resources. So if you look at the waste management hierarchy, so we normally talk about prevention. First is avoid, then prevention, reduction, reuse, recycling. And then we have at the bottom incineration, landfill. So co-processing is somewhere in between where 100% of the material gets recovered and 100% of the energy gets recovered. So it is even better than the waste to energy concept where only 100% of energy gets recovered, but the material recovery is zero in case of waste to energy. So waste to energy therefore is lower in waste management hierarchy compared to the co-processing. And co-processing also is recognized as a recycling technology globally. So therefore, even in the EPR framework that the government of India has announced, co-processing is considered as a recycling technology. So if the brands or the PIBOs are encouraged to send the collected waste, which is their obligation, to send it for disposal or management to the cement kilns for co-processing. So that's the beauty of this particular co-processing technology. And then we are talking about the science of co-processing, wherein this is a manufacturing process. cement, as I said, we are producing something like, 15,000-20,000 tons a day in that cement kiln. So if the waste causes any disturbance in the quality of the cement which is produced, it is a disaster. So by design, there should be no way of impacting the quality of the cement. And therefore, the quality assessment and quality control is the key in successfully utilizing these waste materials. So you need to have the quality assessment in the waste assessment, even waste transportation, then in waste processing, waste utilization. In every aspect, the quality has to be, very critically studied, very critically monitored, and very critically controlled. Then we are able to successfully produce the cement. Because you can imagine that if some material, if it brings disturbance into the quality of cement, 15 to 20,000 tons of material of that day will be out of specification, which is a major cost to the cement industry. So which it will never want to do that. And that's why it is important that the quality is given consideration. So if you are sending your waste material to the cement industry ensures to understand the quality of the material that is coming from your end at their place. How is it getting utilized? How is it getting transported? How it is getting processed? Everything is monitored from quality consideration, and then only it is put into the cement kiln. Different kinds of waste which are suitable for co-processing are municipal, industrial, and agricultural, as I told you. In municipal, we have plastic waste. Then we have the RDF, or segregated combustible fractions, like cloth, paper, plastic, resin, thermocol. Have a variety of other material which are combustible in nature, and also the dried sewage sludge. So these are the materials, and you can imagine, large quantities of these materials tend to get thrown into the environment through our, operating processes of today. But a large amount of this material can be utilized into the cement kiln, and that's what is happening today. You can also have hazardous waste, tire waste, plastic waste, plastic scrap utilized. Also the agricultural sector waste materials. Hello? Hello? Any question?
Sir, you're audible. You can continue. No, sir, you can continue. You're
okay, fine. So there are only two kinds of waste which, there's a concern in utilizing as resources in cement kiln. One kind of waste which we call it as we can co-process only after pre-processing them. For example, e-waste, battery waste, or the municipal waste. So we cannot directly use this material, and we should not directly use this material. There are several reasons for that. Safety is of course one, but second is that e-waste will have a lot of resource materials, rare earths, precious metals, other materials, which can be recovered. So from sustainability point of view, it is better to recover them. Then if there is something which is not recyclable or recoverable, that can be sent across to the cement kiln. So that pre-processing of that e-waste or the battery waste or the municipal waste is important. So you utilize whatever value is feasible out of that first, and then only the material which is reject is sent across for co-processing. And there are some materials which cannot be pre-processed or co-processed. Like for example, the biomedical waste. Biomedical waste cannot be used. Asbestos waste cannot be used. Explosives cannot be used, and the radioactive materials, these cannot be used. Rest all materials that we can think of, that we generate, that are available in the environment, we can utilize as resources into the cement manufacture. So ACC, I told you, as in collaboration with Suzlon, we conducted the trial for demonstrating the safe and sustainable management of FRP in the cement kiln through co-processing in 2009. The FRP material for this trial was shredded to a size less than 25 mm because that was a requirement of that particular kiln. And the shredding was done by Suzlon. And that material was generated in Pondicherry plant. And then it was brought to the ACC Madukarai plant, which is situated near Coimbatore in Tamil Nadu. Central Pollution Control Board, Tamil Nadu Pollution Control Board, both were involved while this trial was being done. And they were witness to the entire trial. And a report of that trial report was submitted to the Central Pollution Control Board and to the State Pollution Control Board. This is a public document, actually not public, but it is basically a, I would say it's a document to the authorities, which is available even with them. So based on these findings and the conclusions of the trial, CPCB permitted the use of FRP as AFR in the ACC's Madukarai plant since 2009. ACC Madukarai co-processed several tons of FRP in next several years. I have not touched Madukarai plant was subsequently stopped for some other reasons, nothing to do with the it was related to the quality of the limestone which was available in that plant, which was very low, and survival was difficult with that particular quality of limestone, and therefore that plant was stopped. But I'm sure this FRP is utilized in several other plants even today in different parts in Tamil Nadu as well as in other locations in Gujarat, etc., etc. CPCB also published a guideline for the disposal of thermoset plastic waste in 2016 based on the results of the trial conducted in ACC Madukarai plant in 2009. And the guideline that I'm talking about is the guideline where I was also a party to drafting this particular guideline. And this is available on the website of the Central Pollution Control Board. You can look at it and utilize the guidelines and the submissions which are there in that for sending across your waste to the cement plants. What is required for the FRP and SMCs to get utilized in the cement kiln? Cement kiln requires a certain specific size, that is the limiting size. It has to be less than that. Then only it can utilize. So this needs to be shredded. So like I said, that Suzlon in Pondicherry had set up a shredder, and then the material that was getting generated as scrap that was sent through this particular shredder. The size was brought down to less than 25 millimeter. That was the requirement for the Madukarai plant. For other plants, it will be different. Every plant may be having different. There are some plants which can even accept 75 millimeters. Some plants can accept 50 millimeters. Some plants can accept even more than 75 millimeters. So, you'll have to discuss that with the cement kiln, depending on the design of the cement kiln, depending on the residence time available, depending on the design of the calciner or the cement kiln as such. The size may be different, the requirement of the size, and that, once you have had a dialogue with them, you can, take up the dispatch of the material to the cement kiln. The shredding, may be required to be done at your end or may be required to be done at the cement plant end. That's a matter of, understanding, because some cement plants also may want to do it on their own rather than you shredding that particular material, or it could be other way around. So that is a discussion point, and you can arrive at for a particular understanding on that particular matter. So this is what I thought I should share with you as a technology, as a concept, and as a solution for managing the waste. I would like to rest here. If there's any questions that you have got, I'll be happy to answer them. Thank you very much.
Thank you so much, Ulhas sir, for the presentation. I think we have some questions in the chat as well, and I'll open the forum to, you can unmute yourself and ask the questions.
Yeah, sure.
Yeah, sir. Sir, good evening, sir. Very good evening.
Yeah.
Yeah, we are from Indocool Composites Private Limited, located in Tamil Nadu.
Yeah.
Yeah. Sir, actually, we need, is there a possibility to share any of the contact numbers, sir?
What I
Or any,
suggest
any
is,
leads?
you can take down my number. You can
Okay.
write to me. I will connect you with the right people. My number
Yes,
is
sir.
my number.
Number,
I
sir?
don't know whether are you able to see my number? No, one sec.
Thank you, sir, for the presentation.
I will share. Hold on.
Thank you, sir, for the presentation.
Sir,
Yeah.
I have a question also.
Give me a number and
Yeah, he's sharing it.
I'm sharing. Just one second. Can you see it now?
Yeah, sir.
So my email ID is ulhas.parlikar@gmail.com and my phone number is 99675 and I have website also. So, but then, this is something which, I don't do anything there. There are cement plants which are capable, they'll be able to handle it. But I can connect you with the relevant cement plants which are around your location so that you can go and discuss with them and finalize.
Yeah, sir. Actually, that's what already we have tried, but we are not able to find that right source actually.
Okay.
Previously we also we have done the same, but for taking the waste we are paying to that cement manufacturer previously. Okay. Now it has been stopped right now. Okay. Now we are sending it. We are giving it to that Tamil Nadu Waste Management. From them, that cement industry they are taking that FRP waste. So now that's what we want to find the right source so that we can directly sell our waste to that cement manufacturer itself. Okay.
What happens is that these wastes, they are categorized under the hazardous waste category.
Yeah, sir.
And these particular wastes, therefore, demand a disposal path which will be given by the local state pollution control board.
Yes.
So they, when in your consent, they would have defined, you can send this material to a waste management company. And the waste management company, they would have written that, you send it to the cement plants for co-processing.
Yeah.
So this is a basically it goes in that manner. Because it is a controlled waste material. It's under the control of State Pollution Control Board. But there's always a possibility that if you directly interact with the cement plants, and if they agree, many cement plants will agree also these days. They are able to do that. And also you should also try to align the State Pollution Control Boards, because they don't understand that this material does not require an intermediate handling by the waste management company. You are reliable and credible enough to send it to a cement plant, which is also a reliable and credible agency. And whatever manifest or processes which are required for the material to prove that it has been done in a transparent and in a what you call auditive manner, I don't think there should be a cause of concern from pollution control board. There are several pollution control boards in the country which are doing it, and they are successfully implementing that. Gujarat is one, Rajasthan is another. I don't know these days Tamil Nadu, because I have not been interacting with them for the past 8-10 years, since I retired from ACC. But you can explore that. There are always possibilities that this can be done.
Yes, that's what we will also write a mail. Okay. Meantime, you can also support us if there is any source of contact, anything
I can.
with respect to that cement issue, you can support. Okay.
Yeah, I'll certainly provide that. Absolutely no problem.
Thanks. Thank you, sir. Thank you so much.
Pleasure.
Hello, sir.
Yes,
Good
sir.
afternoon.
Yes, sir.
Ravi here.
Yeah, Ravi.
Yeah, I'm from Gujarat, Ahmedabad. And my question is that in our factory, there are so many cutting FRP waste.
Yes.
So my question is that how to prevent or manage or can we recycle that waste?
Recycling of FRP, which is a
Yeah.
thermoset, is
Okay.
something which is little difficult. In the sense, I have not come across any very powerful technology which can do that and put it back into a new product. So unfortunately,
Okay.
for the FRPs or for the thermoset materials, the utilization as a resource, as a fuel, seems to be the only possibility today, other than landfilling or incinerating it. So, and in Gujarat, I think you can check up with the authorities, Gujarat Pollution Control Board. There are many good people there. Even the member secretary also is very, very well, fully aware about this particular concept.
Okay.
So if you will request them, we would like to send it to the cement plants, I'm sure they will. And you can, in Gujarat, you can interact with Ultratech, you can interact with Ambuja, you can interact with other cement plants which are there, and they'll be happy to utilize the material from your end.
Okay. Okay. In our factory, the all FRP waste come from nasal cover, wind all.
They come from?
A nasal cover for wind, renewable energy. We
Acha,
actually
sure, sure, sure.
manufacture. We
Correct.
actually manufacture nasal cover.
Right, right. Okay, okay.
Okay.
Fine.
Thanks.
But you can explore that, and it is technically feasible. Absolutely no problem. I forget the name of the authority who is handling these materials. I think there's a lady there, Malini or Malati, something like that. Very, very, very helpful ladies there, who has been promoter of co-processing. She was in my committee when I had set up this committee to make authorities aware about co-processing technology.
Okay.
So you can check with Gujarat, the member secretary or whoever, and say you want to send it, because you can take my name also, saying this is told to be a sustainable technology. We would like to utilize that, and then interact with the industry. I'm sure you'll be able to solve the problem.
Okay. Sure. Thank you so much, sir.
Pleasure.
Sir, and one more doubt, sir. Shall
Yeah.
I, sir? Sir, what will be that, sir? Suppose if the cement industry is taking that FRP waste,
Yeah.
whether they are paying anything to that manufacturer, or if they are paying, means how much will be the, sir, cost per ton?
You see, this is something which is a market phenomenon.
Okay.
Now, what is required to be done is, by doing this activity, by sending it to the cement plant, are you going to save or not, is more important for you to know.
Yes.
So that is, then only you should be sending it. So there are two kinds of saving that needs to be looked at. One saving is the monetary saving. Suppose today, you are sending it to landfill or dump yard or to incinerator, and suppose you are incurring, say, 100 rupees as the cost. Right? And then suppose the cement plant says that, it will cost only 50 rupees to you. So 50 rupees you will pay in. So that's a monetary benefit that you might get, and you may want to go ahead and do that. The other is the mental headache of managing the waste, because it's a statutory material. You have to comply. You have so many documentations, compliance requirements you have to follow, and then you have to go through different audit processes, etc., etc. So there is also a cost associated with that, and the headache associated with that. Some people, and in my journey of utilizing waste material as resources, I'm telling you that these different kinds of situations were there. So some people said that we will pay you some amount because you will take away my headache. Some people will say that they were saying that we will give you the material if your cost of disposal is going to be lesser than my cost today. And there were some people who were saying that unless you pay me, I cannot send you the material. But market will decide, market forces will decide. And you should take a call based on that only. There is no other influencing, process which is available. No authorities, no cement plant association, or no, any, what do you call, senior industry leader can change that particular situation.
Fine, sir. Understood. My doubt is what is exactly happening in north side in Gujarat or Madhya Pradesh?
Yeah.
Whether that supply cement industry they are paying or just that manufacturer is paying to them.
See, if it is becoming beneficial to them by paying, they will pay. If it is not beneficial to them, they will not pay. See, for example, I'll tell you an example. I'll tell you an example. Suppose you have the RDF from the municipal solid waste. If it has got, say, 40% inerts and 40% moisture, that means there is only 20% useful material in that. So if cement plant is asked to pay by the authorities for that RDF, cement plant will never pay because it will never work out for them. But suppose if it is, say, 10% moisture and say 15% inert material and 85% is a good material, combustible material, and its calorific value is good, it can be accepted, I mean, it can be used easily, they will pay. Today, there are many cement companies, who pay for this, even the municipal solid waste or the RDF from municipal solid waste. So there is a market approach for the pricing. For your material, you have to check how it is.
Oh, okay, sir. Fine, sir. Thank you, sir.
Yeah.
Thank you so much, Paul. Prashant, sir, you had some question. You raised your hand.
No,
Yeah.
I just wanted to thank Ulhas ji. Basically, I recently met him at MRI conference. We had a common session.
Correct.
And yes, cogeneration is the solution today. But then, what are the other solutions, Ulhas ji, when we can think of? Because I think by 2030, around 40,000 tons of wind turbine blades will be coming down.
Mhm.
And how are we going? That will take,
Yeah.
even the cogeneration will not be able to take up those
No,
waste.
sir. No, Prashant, sir. I can tell you that cement kiln has got huge capability to utilize the waste materials. See, if let's take a cement kiln, say, let us take the Ultratech cement plant in Gujarat, right? It produces something like 10,000 tons minimum of clinker. That means they use about 2,000 tons of coal as fuel. So 2,000 tons can be replaced 100% with any waste material. That means 2,000 tons per day of waste can be utilized in that particular cement kiln, in one cement kiln. So potential is very high. See, since I'm telling you that today I said 6 million tons of waste is utilized, this is contributing to only about 8% of the fossil fuel replacement of cement kiln. That means, you can add almost about 12 times more waste material into cement kiln to achieve the technically feasible number of 95-96% replacement. So 6 into 12 is almost about 70-80 million tons of waste can be utilized in the cement industry. I'm saying, but
continue.
Feasible.
No, then my question comes, why that things are not been so encouraged, or why there is so much of restriction? Because everybody in composite industry is worried about their waste, and they have been questioned by Pollution Control Board and hazardous waste departments to look at it. And unfortunately, there is no supply chain mechanism which basically is been placed in a proper manner.
Yeah.
If it should happen, then basically I think there should be no problem for the total composite industry in India is not so big. You can say one big cement factory can take away all the material which is going to be generated.
Sure.
So we need to look at that aspect. What I feel is that the supply chain mechanism needs to be worked out. There should be win-win situation from the both end. Now, I was in Syntex. I used to give to Ambuja Cement a huge amount. Daily 3 trucks or 4 trucks of material was going from here to Ambuja Cement.
Right.
But again, the question was asked by somebody, Mr. Dinakaran or somebody, I think so, that who is going to pay, me or the Ambuja Cement? And it was seen that I was paying for the transportation.
Yeah.
Because at that time, basically, the question was that you give us the thing, we'll use it. And that was
Right.
an obligatory thing. Ambuja
Right.
Cement was obliging Syntex that they are using their waste.
Okay.
So that is what is important, that if
Right.
the value chain mechanism and supply chain mechanism is monitored or controlled, we need to work in that direction. That is what I would request
Agree with
you also as a MRI representative and director of that.
Yeah.
We need to look at the supply chain mechanism. Like rubber industry is now gaining very good results.
No, certainly. So that's why I'm saying, there has to be a market process in place where it is win-win. Then only it will get
Yes.
utilized. In tire, what happens? The waste tire, is going to get utilized as crumb rubber or as a, in the what do you call, road construction or for oil production, which there is a economics associated with that, and therefore it is thriving. If the economics is not there, it will never work. So if the cement industry is going to gain and you are also going to gain, then there is a win-win possibility. And we need to look at that where that particular win-win is there. Today, municipal sources are able to find that opportunity. Today, large amount of dump yards are getting remedied, wherein the RDF from the dump yards is going to cement plant. Cement plant is able to receive this particular fuel at a price much lower than the cost of coal. Therefore, they are utilizing it. So if it is lesser than the cost of coal, they are happy doing that. Now, if it is more, so we'll have to look at that possibility. Why is it that it is more? If it is more, there could be several reasons for that. So whether the supply chain is not right, whether the mechanism of processing is not right. I think if we go a little deeper into that, we'll find a solution.
No, we need to
And I'll be happy
work
to
in that
work on
direction.
that.
And that is what the associations and the expert teams should
Correct.
work along with the administration and come to a conclusive thing, because there's a lot of noise about composite and people are taking as a very negative about its non-biodegradable or basically thing, recyclability. But if this is a solution for this, I think that there's a good thought process to be think of, because if you see the applications which are now going in composites are beyond people thinking about. Defense, aerospace, and other industries are taking composite as very serious material.
Correct.
And now, if that industry is going to grow, I think the waste is also going to grow. And that, if it is not being utilized in an appropriate manner, or basically there's no value for it, there will be again a huge confusion and question arise about this material.
Certainly agree with you, Prashant, sir. I think we need to look at it, and I'll be very happy to support any initiative that we as association at Gujarat and as MRAI, if we have
to work. I think I would like to be part of that discussion, and that we should bring down basically CECA, basically FRP Institute, and even Composite Association of Gujarat to work together and look into this aspect. I think so.
I'll be happy to collaborate. Happy to collaborate, sir.
Thank you very much. Thank you, sir.
Thank you.
Thank you. Thank you so much, Ulhas sir, for the presentation. Any questions, anybody? I think we are good here. So,
hello.
Yeah.
Yes.
Yes. This is Prashant from Priyo Composite. So I want to ask that can we use this waste in building materials and warehouse applications and kind of that?
As a construction material, I would be very, very, I would say, optimistic that this one should be able to use that. But I have never come across any reference or trials or any specific demonstrations where this has added value as a composite material. I would suggest that maybe we should discuss this with some of the technology promoters or with the institutes, research institutes, to check whether something is done. I had done a substantial survey while we were drafting that guideline in 2016. And at that time, at least that time, there was no utilization of such materials in the construction industry was seen as workable. But given the nature of the material, I feel there is an opportunity, but it needs to be developed. So somewhere I think, I don't know how this can be promoted as a possibility, but can be explored, should be explored.
So is it okay? I'll connect you later on to discuss particular thing on like further.
No problem. I'll be happy to.
Okay. Thank you, sir.
Thank you.
Thanks a lot. I think we have several Prashants in the room today. Thank you so much, everyone. I think it was a really wonderful session. Thank you, Ulhas sir, for imparting and sharing knowledge around this. And we hope to see more of such sessions around sustainability in 2026. And as shared by Prashant sir, we hope to have a much more collaborative approach towards this. So thank you. Thanks a lot, everyone, for joining.
Thank
And to seek more updates on such webinars, please follow CECA Asia on LinkedIn, and please keep visiting ceecaasia.org to get such updates on courses and the webinars. Thank you so much.
Thank you, audience. Thank you very much. And
Thank you.
Thank you.
Raj.
Thank you all.
Thank you. Bye.
Thank you, sir. Thank you.
And thank you once again, Parlikar sir, for giving your such wonderful knowledge and giving us your precious time, sir. Thank you so much.
Thank you. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.